Hi guys, Mrs. Suya here. Today's topic is section 3.4, where we solve linear systems of equations that have three variables. So um, just a quick summary of two variables. So when you have two variables, we have like an x and a y, and those always graph a line. And when you put two of them together, you'll get two lines, and you try to figure out where they intersect. So what does three look like? So here's like a three variable equation. And here's what the three variable equation graph looks like. So we have another axis that gets added on here. So this one is supposed to look like it's coming out of the screen towards you. And it is relabeled as the X. All right, this horizontal one gets relabeled as the Y, and the vertical one is labeled as the Z. And we are not going to practice graphing these. We kind of don't have time this school year, but I'm going to go ahead and show what it's going to look like once it's graphed, just so you get the idea. All right, so essentially, when you actually try to graph a three-dimensional graph, they look like little triangles drawn on the plane because all you mark are their intercepts. This is a z-intercept, a y-intercept, and an x-intercept. But you'd have to picture the plane going on forever in all of the directions. So it really does graph a plane. And so when you think about getting three planes on the same grid, you can understand that it would be way too hard to try to figure out, a solution for where three planes could possibly intersect on a grid. However, here, this is straight out of our textbook. Here are the types of solutions that we would be getting, and we're going to be doing this algebraically, but here's the visual that goes along with each one. Sometimes three planes really do intersect at a single point, all right? And that it would be like what this is showing right here, that single point. Sometimes they intersect along a single line, in which case we would say that it has infinitely many solutions. And sometimes there is no solution. So clearly this one on the right here, three parallel planes, they never intersect one another. But even if like two of the planes are parallel, it doesn't really matter what happens to the third one. There's not going to be a single solution for that system of equations. And here, they don't intersect at an exact point or line. So this is also an example of a no solution. All right, I'm gonna jump over to the document camera where we will figure out how to solve these. All right, so we have these three steps broken down, and we're going to start with step one, which is we are going to look at our three equations and eliminate the same variable from two pairs of the equations using the elimination method. All right, so I'm going to kind of investigate my system of equations here. And remember that I want to eliminate the same variable from two different pairs of equations. So even though the z's are looking pretty good between these two pairs of equations, I would have to eliminate z from a different pair, in which case I'd have to pair one of these guys up with the 6, and then it's not looking so good. So I think the y's are the way to go here, or the x's. I'm going to go for the y's. All right, and you'll find that staying organized ends up being super important with this because it's easy to make a mistake, and if you can't follow any of your work, then it's hard to go back and figure out where you went wrong. All right, so if I just kind of consider equations 1 and 2, to cancel the y, I need this to be a minus 4y, so when I add them together, they cancel. So I'm going to times this first equation by a 4. So that just means I'm using equation 1 and I'm going to times it by a 4. So that's 8x minus 4y plus 24z equals negative 16. All right, and then I'm not actually going to touch equation 2, but I'm going to use equation 2, so I'm going to just put a little 2 there to show that this is equation 2. So that becomes 6x plus 4y minus 5z equals negative 7. Okay, now I'm going to add together, and I need to eliminate one of my variables. If I don't, then I got something wrong. let's see what that looks like. Plus 19z equals negative 23. Okay, so this is a new equation that I'm going to end up working with in a bit. I'm going to just number that equation 4, because that'll be my fourth equation. Okay, now I'm still not done with my step 1. I need to go and pick another pair of equations and eliminate the y. So I would probably go back to equation 1 again with equation 3. Right, so if I look at the y's on 1 and 3, if I could make this y become a plus 2y, it would cancel with the minus 2y. So to make it become a plus 2y, I would need to times this one by a negative 2, right? Multiply the top one by a negative 2. Okay. So that's going to give me a negative 4x plus 2y minus 12z equals positive 8. All right, and then I'm just going to recopy equation 3, which is negative 4x minus 2y plus 5z equals 9. All right, now I'm going to add my two equations together. I'm kind of off the edge of the paper there. The y's once again cancel. You have to cancel the same variable on this first step. That's minus 7z equals 17. Okay, this is going to be my equation 5. Okay, so now that was step 1, right? I eliminated the same variable from two pairs of equations. All right, now I'm going to solve the new linear system, as in the resulting equations from step 1, for both of its variables. Okay, so now I'm going to make a system of equations from 4 and 5. So I'm just going to recopy 4 and 5 down below here. You'll find you take a lot of paper for this stuff too, so plan well. You need to save space for you to show your work. Okay, so now I am going to cancel something from here. And just the way that these resulting equations ended up, I did end up with some big numbers on the left here. I'm thinking the x is going to be the easier one to cancel. I know I could just multiply the top by 8 and the bottom by 14, and that would do it. Then I get really big numbers. I think there's a smaller solution, though. I think that 14 is, what is 14 times 4 is 56. Yeah, these can both become a 56. So if I multiply this whole equation by 4, I didn't really have good space there. Then this one becomes 56x plus 19 times 4 is 76. 76z. 4 times 23 is 92. 92. Okay, and then this one I'm going to multiply by 7, because I'm going to get a negative 56x plus 49z equals 7 times 17 is 119. Okay, so this is old school, right? This is what we practiced in section 3.4, and that is the elimination method with two variables. So I add those together, and those cancel. And let's see, I think I dropped a sign. I think I goofed up on a sign here. There was nothing that would have switched that to a plus, right? It was minus here. I times by a positive 7, so that's supposed to stay minus. Okay, so 76 minus 20 minus 49 is 27. And 119 minus 92 is also 27. All right. So z is equal to 1. Yay, we got our first answer here. All right, and now, we're just still working with equations 4 and 5. We're going to take that 1 and plug it back in for the z on equation 4 or 5. It doesn't matter which, but the numbers on 5 seem a little bit smaller, so maybe I would do that. So negative 8x minus 7 times 1 equals 17. Negative 8x minus 7 equals 17. 24 divided by negative 8, so x is going to equal negative 3. Boop, negative 3. Okay, so we've got the x and the z. All right, I think all this part is step 2 from those 3 steps above. Okay, so I solved the new linear system as in the resulting equations from step 1 for both of its variables. So I'm going to check that off. Right, and now step 3 is going to be to substitute the values found in step 2 into one of the original equations and solve for the remaining variable. So now I'm going to go back up to equations 1, 2, and 3, the originals, right? And I'm going to plug 1 in for the z and negative 3 in for the x. So let's see, which equation do I want to choose? I'm going to just choose 1. It looks like the smallest, right? So I'm going to plug a 2 in for the x. Nope, I'm plugging a negative 3 in for the x. I'm solving for the y, and I'm plugging a 1 in for the z. And that's equal to negative 4. Okay, so I'm going to just solve this. Negative 6 minus y plus 6 equals negative 4. Negative 6 plus 6, those go to 0, so I get negative y equals negative 4. So y equals positive 4. All right, so my 3 answers are negative 3, 4, and 1. And so typically when you give a final answer, you give it in x, y, z order. Negative 3, 4, and 1. Okay, example 2. Let's see, so solve the system. And so first we have to investigate which variable looks like it's going to be the easiest to get rid of between the 3 equations. So I'm thinking the y's once again. It doesn't have to be the y's, but the y's once again on this one. All right, so I'm going to go ahead and number 1, 2, 3, and maybe you can already see what's going to happen on this one, but if I want to eliminate the y's between 1 and 2, what I end up doing is multiplying the equation 1 by a negative 3, because then this is going to become a negative 3y. So we're going to end up with negative 3x minus 3y plus 3z equals negative 6. And we're not going to do anything to equation 2. Just recopy it. But the y's did cancel. However, so did the x's and the z's, which means you are left with 0 equals 2. And what that tells you is that there is no solution, and that means that these planes right here would be parallel. So if just the first 2 planes are parallel, you don't really need to even do anything with the third plane. You're never going to find a solution for the system as a whole. So this problem actually ends right here with a no solution. All right, and example 3. So once again, let's investigate which variable looks like it would be easiest to eliminate from all 3, even though we only ever work with 2 at a time. And I'm thinking that it's y again. All right, so I'm going to just look at equations 1 and 2, and the y's are going to cancel straight up. So x plus y plus z equals 6, and x minus y plus z equals 6. I don't have to do any multiplications or anything. If I add them together, I get 2x plus 2z equals 12. All right, so that's my equation 4. All right, and now I think I'll, going for the y's again. So now you need to pick a second pair, and eliminate the same variable, it's going to be easiest if I use equations 2 and 3, and I don't have to alter them at all because the y's are just going to naturally cancel out when you add them together. All right, so we'll go ahead and add these guys together. The y's are eliminated, hence the elimination method. So now we have a new equation here. All right, and we'll call that equation 5. Now we're going to go ahead and put equations 4 and 5 together. 2x plus 2z equals 12, and 5x plus 5z equals 30. Okay, let's see. So if now I just have to choose which one to solve. I mean, you can kind of see what's going to happen. Maybe, we'll see. So I'm going to go ahead and multiply this one by, say, a -5. And I'll multiply this one by a 2. And I am going to try to cancel the x's. I think that's going to happen with the y's also. We'll see what happens with the number. But I'm going to end up with a -10x minus 10z equals -60. And this one's going to be a positive 10x plus 10z equals positive 60. Okay, so I add these together, and both of my variables are eliminated. And so the number on the other side also goes to 0. All right, so I can't finish actually solving this. And I did use all 3 equations here, and we worked our way to a point where it is we are no longer able to solve it. But what we have left is a true statement. All right, so that tells me that I have infinitely many solutions. Let's see, infinitely many solutions. So this is that picture. I don't know if you remember the pictures from our book where all planes intersect along a line. And since the planes go on forever, so do the lines. Oh, so does the line of intersection, which is why there's infinitely many solutions. Okay, and last example, we won't solve this one, but we'll go ahead and get it set up. It says, at a carry-out pizza restaurant, an order of 3 slices of pizza, 4 breadsticks, and 2 juice drinks cost $13.35. A second order of 5 slices of pizza, so once again, it's another pizza, 2 breadsticks, juice drinks cost $19.50. And then the third statement is if 4 breadsticks and a juice drink cost 30 cents more than a slice of pizza, what is the cost of each item? So let's go ahead and define the 3 variables. X, Y, and Z are basically our 3 food items. So the X will go ahead and be the number of slices of pizza. The Y will be number of breadsticks. And the Z will be the number of drinks. So we should be able to set up 3 equations here. So the first one, it comes from the first sentence. So it's 3 slices of pizza. You know, I said number of. I think that's not right. The cost of a slice of pizza and the cost of a breadstick and the cost of a drink, right? Because this would be 3 is the number of breadsticks times however much each breadstick costs. This is the total dollar amount you're going to be spending for breadsticks. All right, plus 4 times the cost of the breadsticks. Or pizza, I think I said breadsticks there. And then 2 drinks. And Z is the cost of a drink. So if you have 2 of them, 2 times Z would give you the total cost of the drinks. So this is how much money that you're spending. All right, and that dollar amount totals up to $13.35. All right, the second order would be 5 slices of pizza. So 5 times X. X is the cost of a slice of pizza. I'm going to fix that. Dollar of one slice of pizza. All right. 2y for the breadsticks, and there's 3 drinks, and that costed $19.50. All right. And then the last sentence says if 4 breadsticks, so 4y, and a juice drink, cost 30 cents more than a slice of pizza. So here's 1 slice of pizza. I'm going to put it over here on the right. And then I'm going to add 30 cents because the left-hand amount costs 30 more than the pizza, 30 cents more than the pizza. So in order to make the two sides equal, you'd have to add the 30 cents to the pizza side, and then these two sides would be equal. Okay, so we'll call this equation 1, equation 2, and just to line them all up, we'll kind of alter this third equation so that it says negative x plus 4y plus z equals 30. And I would use that as my third equation for solving this system of equations. All right, good luck to you. Remember, try to be organized and take your time, and don't get too frustrated because sometimes these problems do take a